Francesco B.
Te me expert essere ebből. Expert essere ebből, hogyan lőjük össze egy percet.
Well, welcome everybody to a new talk from Doppler Labs. This talk will be about tooling, asking your neighbor a screwdriver or getting your own. I know that's not a screwdriver, but I'm crazy like that. In this talk, we will talk a bit about what is tooling, the types of tooling we use daily, how to start implementing tooling, how to get into tooling yourself, and a kind of conclusion for it. So, what is tooling? I think everybody more or less knows. So, tools are so well in a rough way. Tools are just something. It's a quite generic concept that we define and then we implement or we create for everyone to make their daily stuff easier and faster. In our daily job, there are a lot of types of tooling. First, before we start coding, one of the basic toolings we have are the paper and the pencil. We have to put our ideas somewhere before we start coding. Then we also have declarative drawing like UML diagrams for things like UML, class diagrams, use cases, flow diagrams. There are a lot of different types of declarative drawing. Before we start coding, we also have a lot of options like a lot of tools that allow us to get source from other people or free code. We have to be careful and we should learn a bit about code licensing because we may be able to use what we get, but later we may get into some trouble, but this is a completely different topic that it's also quite a big topic. Then we also have package managers, we have frameworks, we have libraries. We also have third-party vendors for getting in a faster way stuff we may need. And then as a last step, we also have to ask ourselves if our current technology is the most appropriate choice. For example, if we go with some project where we need serious parallelism for processing, maybe we are doing a wrong choice. We should go with some functional programming language or some other type of environment. Then after we make this first step, we want to start writing code, and for it we have also a different complete set of tooling. We have IDEs, we have rapid application development tools, we have other types of editors like Vim, Emacs. Then it's also important to make and to learn to make an efficient use of the web, and even things like local libraries, user groups, to meet other people. We can always make our work in a faster way if we learn how to use these resources. Then we also have build tools like Ant, Nant, Make, Maven, MSC Build, and a lot of other tools that are not exactly for building the code itself, but for helping in this process. And then overall of it, we have the continuous integration and delivery systems like Jenkins, TeamCity, Bamboo, Travis, and a lot of others that will help us to remove from us the need to constantly test our code, to build it, to deploy it, and a lot of other steps. Then, after we finish our projects, we have to improve our code continuously, and we have more tools like tools for debugging. We have tools for logging and controlling the flow of our applications, like syslog, log4j, the standard output, event managers. We have static analysis tools for checking our code base and giving hints or some warnings or useful information how to improve our code, like check style, JLint, FXscope. There are a lot of them, depending on the technology we use. After this, we also have code and design reviews for helping us to review the code from ourselves or from other colleagues. Maybe the most famous one is Review Board. Then we also have tracing tools like Process Monitor, Wireshark, Valgrind, that they will allow us to check, to make sure that our software is making what it's expected to make in a lower level, to make sure that we don't have any kind of problems that we didn't really see in our previous steps. We also have tools to compare differences between files, to check the checksum of the files, to check differences between different files, to make sure that the files we are using are the right ones, that we, in some step, there was nothing that made changes to the files, or that we didn't fail in some step. And then we also have refactoring tools that allow us to make a lot of things like rename variables, I don't know, implement missing features in an easy way that are normally integrated into the IDEs. But we also have the rough tools like a quick edit and replace, set, and a lot of other possibilities that, okay, maybe they will bring a lot of problems, but if we are smart in its use, they will be fast, and we can easily find problems just when we compile. We see the problems, and we can quickly fix all of this stuff. Then we have tools for different kinds of operations and the work environment, like virtualization, like VirtualBox, Docker, Vagrant, QEMU, that they are useful to put our projects in a box, to test it, to test different kinds of environments. If there is a problem, we can easily roll back to a previous state, and it won't compromise our current workstation or the company network. We also have system configuration management tools like Puppet to remotely run and manage applications. We have service orchestration tools to do similar things with services. And then maybe more, in a more important way, we have version control systems that everyone knows. They are really important. We should use every day. It doesn't really matter if we work alone or in a team. They are always useful. I think most of the people here knows about them. They know the differences, that nowadays everyone is familiar with things like centralized repositories, distributed repositories. We know Git, Mercurial, SVN. There are some other paid solutions that are famous, like Perforce, and all of them have different properties and advantages. Then we have many other type of tools. We have communication tools like Skype, Mails, Google Hangouts. We have wiki tooling like Confluence, SharePoint. We have issue tracking, project management, and collaboration tools like Jira, Pivotal Tracker, Redmine, UTrack, GitHub. That, well, it's mainly used for open source, but it can be also used for issue tracking and project management without a problem. We have collaborative editing for things like working several people at the same time in the same file, remote monitoring systems for like TeamViewer for solving problems in a remote PC or checking what a PC is doing far from our place. We have deployment servers in the cloud like Amazon. We have Microsoft Azure, Heroku, and there are many more tools out there for localization, for file sharing like Dropbox or Google Drive. We have also tools for payments. We have tools for A/B testing, IT support. There are tools for every need out there, and even more. But then we also have to realize that, okay, we are developers. We see every day these kind of tools, maybe some more than others, but this is not the only tools we use daily. There are also tools like work methodologies, and inside them there are also another kind of tool sets like Agile, Kanban, Lean, Extreme Programming, Scrum, Waterfall. There are many of them. I'm not an expert in this area, so I cannot delve a lot in it, but I'm sure that you know about it. There is also team tooling that they can help the teams to move forward, to have an easier communication. And then there are tools like finding things in common. This is useful for management. Sometimes when you want to work on some project, you may want to make a team of people with things in common because they may be able to make some stuff faster, or you may want to put people that don't have things in common to use the knowledge of everyone in a different way together. Then we also have the Fist to Five. I don't know if you know it. It's when someone has an idea or something to do, the whole team decide if this is interesting to do, and they will decide how important is it using the hand. So they will use fingers to give a value to the idea, and depending on the overall value, you will decide on working on this idea or not. There is also the 5x7 priority that in this tool we will have something like cards. Everyone will put an idea or feature to work in each card, and then everyone will get a card. They will put different points to it, giving their, let's say, their value or their what they think that is the priority of this task, and they will every time they will cycle the cards, and in the end the cards with the biggest points will be the task to do. We also have the collaboration contracts. In this one we will make it's maybe a bit hard to explain out of words. We will take the roles of everyone in a company, and we will make a matrix, and depending on the role, everyone can make in the process, in a decision process, they will have a role, but they cannot have more than one. And in this way, we will avoid problems when someone has too much power and can decide all by themselves the whole process. And there are many other tool sets depending on the categorization we make or the purpose. We may have time management tools. We may have motivational tools, process of optimization, either for micro or individual processes, for a group at a global level. We have the hardware. It's another kind of tooling that we use every day, and many others. And then, how to start using some tool set? How are you going to implement it? Well, first you have to get the knowledge of the tooling you want to implement. It's not easy sometimes. You have to read a lot. You have to play with it yourself. It's good to read about previous experiences. You have to know the current solutions. You have to know other solutions. You have to know the weakness and the strengths of the solution you want to implement, because in the end you will face the wall sometime. It's not possible to take into account every possible use case of something, and you will face a problem sometime. So it's a quite common problem. Sometimes you implement some really new technology, and at some point you have a problem with it, and what to do? You Google for it, you ask somewhere, and you find that no one else had this problem. So this is also something to take into account. Then when you have all of this knowledge, you have to sell the idea. You have to start the fight. This is more psychological than technical. Well, if you work alone, it's not a problem, but if you are in a team, if you are in a big company, you will have to do the role of a salesman. You will have to go to your manager or whatever, and you will have to state your case. You will have to really explain in depth why you think this new tool is better than the current one. You have to be able to reply to questions like, does it integrate well with other parts of the environment that we don't want to change? Is it secure? Can we implement it iteratively? Because if you change the whole tooling in a single step, it may be a chaos. You have to be able to have a training plan or something because the tools are not used themselves. Someone has to use them. So you have to be able to provide some person to use the tool, and this person should be able to use the tool at its most, use the most of it. Otherwise, maybe it would make sense to use a new tool. And also, you have to be ready for constant reminding that it was your choice to use this new tool. When there is a problem, there will be someone that said, ask this guy, it was the one who said that this is better. So it's also a stress on the person trying to implement a new tool. Well, some of you may ask, can I do this myself? Can I work on tooling myself? Well, why not? The typical question or the typical reply against this is the reinventing the wheel, let's say, anti-pattern. I think everyone here knows about this. I would say that it's 75% true that it's an anti-pattern, but it's 25% myth. Okay, you may reinvent the concept of the wheel, but not the implementation or the properties of the wheel. You can go outside and you can find different types of wheel, and it's normal. When you decide that it's good to go for it, you may need to find different motivations. There are many. It can be, as I said, that the current tooling doesn't fulfill your needs. It can be that the current tooling has a really bad user experience, that it's really cumbersome to use, that it's really hard to use, that you need to do a lot of context switching to switch from your daily work task to use this tool. There are really many motivations to work in it. Also, as we are developers, it can be also for the fun of doing it. It doesn't need to be any real motivation for it. Then when you decide to work on it, there are different methods for creating tooling. We can composite or chain different existing tools. We don't need to create something from scratch. There are some guys that says that for every need, there is a combination of Unix command line tools that will solve your problems. There are even more, there are people that say that you are not paid to program, you are paid to solve problems. So you don't really need to program a new tool if you can reuse a lot of other tools. As long as it solves the business problems, it's okay. You can also work on extending existing tools. You can create your own tools. You can use a mix of the above. Or you can even use tool sets that allow for tool creation. You can create with some kind of DSL or some documentation description language. You can create your own tools with some of them. If anyone worked on language parsing, it's common in, I don't know the pronunciation, ANT-LR. Yes, you can do something like this, or with diagram tools, it's possible. When you want to work on your own tooling, there is a first stage. You have to take the environment into account, because every tool will run in a different environment. You can look into other existing environments to see if you can reuse something that is already in the other environments. You can also decide if your tool will also be useful in other environments. And then you should also be aware of the limitations of the tool you plan to do, and also the full potential it may create. Then in the implementation stage, there are different ways of creating your tools. You can reuse the available tools in the system. You can look into available SDKs. You can look into the APIs that other tools or the operating system provides. You can, with these APIs, you can get information from outside. You can maybe, depending on the application, you can create plugins. Maybe the application provides scripting possibilities to extend what it offers. And in the end, you have to analyze the ecosystem. You have to collaborate with more people. You have to be positive all of the time because it won't be easy. You have to be open to constructive criticism, and it's important to look into other alternatives because you may learn how other people solve some problems. You may find out that you can reuse the solution of other people. You can find that you can combine some tool that you didn't know. And in the end, you will be able to have your tool, but it may not be easy depending on what you want. In the end, what can you do? You can go live with the tool. You can keep it for yourself. If you decide to go live, there are a lot of options. You have nowadays different kinds of stores. You have, well, local stores, physical stores. You have digital stores. You can decide to publish your work as an open source under some license that it can be reused by other people. You can decide to publish your work online in some user group or mailing list, in communities, in news sites, in blogs, in article sites. You can try to spread the work in conferences. You can do it by word of mouth, telling everyone, oh, I'm working on this, what do you think, would it be useful for you? What do you think of this problem? Do you happen to have the same problem? In the end, it doesn't matter what happens, I think. You can get a lot of experience, you can meet a lot of interesting people, it can open a lot of opportunities for everyone. And after you finish this stage, you should relax. You should take a few days for yourself to think what you did, if it was really worth it. I think it would be really strange for the staff to not be really useful. And as a final step, I think it's the best is to go on to do like in other processes, to refactor, to start from scratch and try new things. Or maybe you found out that what you did was really useful for people, and you can see new improvements for it. You can work on new ways of extending the, I don't know, documentation, the usage. Maybe you find that you can reuse the tooling you made for a different work environment. It doesn't matter. Just go on. And I think this is most of the introduction of tooling, and hopefully there will be more talks.
What's the conclusion with the teacher?
Okay, yes, I forgot. As a conclusion of this, I would say that tooling for us is like the teacher was in the school when we were children. If you passed a test, it was because you worked really hard, you succeeded, you did a really good job. And if you fail, it was the teacher's fault. So it's the same with tooling. When a project is successful, it was because you did a great job. If the project was a failure, it was because you didn't have the tooling for testing, you didn't have the tooling for developing in a faster way, you didn't have the tooling for doing something in a nice way. So,
Thank you.
and I think I don't know if someone has questions. This is a really big area to explore, and I'm sure I forgot a lot of things to say.
Yeah, I think there is an interesting part of tooling because it's kind of evolution normally. I mean, we were still going and hunting down animal by teeth and knees and nails, but we invented tools for it. So actually, tools are the basics of for evolution. But the real point is that how to get that attitude to realize I just repeating myself and I need a tool for this. Because I think normally we replace things with tools that we already understood. You get the point, and we can just say that we can get rid of this problem ourselves, and we can just give this problem to a tool.
Well, the most common way of this is when you repeat a task a lot of times, you often look for a tool doing for you this repetitive task. A lot of times it's also a bit like the egg. What was first, the chicken or the egg? So a lot of times it's also what was first, the need or the tool. You may anticipate some needs, so you work on tooling. Sometimes the evolution may come from the needs. Sometimes the evolution may come from the tool itself. As time passes, you have more power to do more stuff. You devise a new tool, and you find out that thanks to this tool, you can do stuff that before you couldn't do, or you could do, but with a lot more of work.
And it's very ambiguous now. I mean, who is the tool, who is the need? I mean, because sometimes just an application is a tool.
Yes,
It's a tool for an application, so it's a tool of the tool. So
yes,
it's an understanding.
I said it at the start. In our world, tool is a quite abstract concept. I think most of the things are a tool for us, and if they are not a tool, we will make a tool out of them. I think.
And the tool itself actually forms your environment. I mean, we use windows as tools to get light in, but keep the heat. And this is a tool, but after it makes a boundary of your environment.
Yes, and
your
a lot of
lighting
times
tool.
also.
Who is
A lot of-
Christina? It's a tool?
a lot of times tools will also, let's say, will force the way we take for doing some things, and will also force us to use other tools. For example, like in the case of Windows, maybe you want to use some tool that it's in, I don't know, in Mac, but it's not in Windows, so you will look for something that is similar in Windows. So it's every time like this. Don't know.
Thank you, man.
No?
Anything else?
Oh, thank you.
Thank you, Andras. Thanks a lot.
Sorry for the delay.
No problem.
I think the tools that come before the need are